Good morning everybody and welcome back to the channel. Now this video is gonna be a quite long, but it's gonna be a very informative video. This video we are gonna learn how to build a universal data lakehouse using Apache XTable, MinIO, StarRocks, DeltaStreamer and interoperate between Hudi, IceBerg and Delta. Not only that, we will also be building a complete multimodal index, which means we are going to build the record level index on the top of Hudi. We're also going to build the column stat index on the top of Hudi. That's multimodal index. Then I'll also show you the data skipping features on the top of that. Not only that, I'll also show you how record level index helps you to achieve 70% faster point lookups. I'll show you also how to read the data as IceBerg table, how to read the same table as Delta table. Not only that, we'll also query this data using StarRocks. So if you see, there's a lot in the video. It's going to be a long video, so I hope you enjoy. Before we get started, I want to make sure I point out this blog. I took a very good, decent time to write this blog. This blog has all the necessary steps that we're gonna do in this video, right? Everything is explained in quite detail, the steps, the jar file, the settings, everything is explained, right? So that's that. So without wasting any further time, we will begin the complete lab session. So again, it's gonna be fun. There's a lot to learn here, so I don't wanna waste any further time. So let's rock and roll straight into action. All right, so here we go. Let's rock and roll, guys. All right, so the very first thing that you want to do is first, clone and make sure you have all the project folders and files, right? That's the first thing that you want to do, right? So let me navigate you slowly and not overcomplicate things. So when you download this, make sure you have a folder called jar. Inside jar, you need 3 jar files: Hudi -utility -slim -bundle jar, Hudi Java client and Hudi extension snapshot jar. These 3 jars are important. Okay. Make sure you have the Docker compose file because that would be used to spin up the entire stack. Make sure you have 3 Python files: read_iceberg, read_delta, dataskipping.py. After that, you will have a folder called sample data. Inside that, you would have a folder called datagen.py, right? So make sure you have all of these inside. And what else am I missing? That's about it. So let's get started. So okay, so the first step before you do anything, right? Clone the repository. First thing, let's generate some data to play with, right? Some fake data. So let's come to sample datagen.py, and what I will do is simply right click and simply run the Python file. So when you run the Python file, you will see 2 folders that have been created: customers and order. And they both should have some 1 or 2 CSV file that you can play with, right? So hopefully that made sense. Now the next step that we want to do is we want to spin up the entire stack, right? We want Hive Metastore, we want MinIO containers, we want StarRocks FEBE containers, so all of that, right? So I tried my best to simplify that through a compose file. So the most easy way would be open your project directory. Here you will see all the containers, right? So come here and simply fire a command docker. Let me make sure my Docker desktop, do I have it? Yeah, I do have it. Let me make sure I don't have any containers running right now. I think I have 2 containers running, the StarRocks, so let me stop that first. Okay, I think that should be good enough. First, let me make sure Docker system prune. I'm gonna do yes, okay, looks good. All right, so you can spin this up using docker compose up -- build, and then we'll put a flag called -t. Now this will take time because again, he has to download all the images, right? So enter. I already have these images from the past, so it would be pretty fast here. So now if you observe, I should have at least 6 containers running, right? Hive Metastore, the MinIO container, StarRocks FEBE container, right? So make sure that all of these containers are in the running state. So let me collapse, let me go to the containers and try to collapse this. Yep, I have all the 6 containers running, okay? So hopefully made sense, right? Now, what you want to do is, hey guys, open up Chrome. Let me open up a new tab. Head over to localhost 9000. This will prompt you with a username, password. The username is going to be admin. Password is going to be password. Click login. Now go to buckets and click on create buckets, and let's call this bucket Hudi test. And we have this bucket over here, right? So now the next step is, what we need to do is we need to ingest the data, right? So remember we made that sample CSV file. Let's use DeltaStreamer and ingest this data into this MinIO bucket. So we'll take a look at the steps now. Yeah, this video will be a little long for sure, because if I'm explaining every single thing, this video would be long for sure. All right, so where are we? Yeah, so we'll go to the Spark Submit job, and then I'll explain you all of these, okay? All right, so let's go slow. All right, so class, we're gonna use art.apache.hudi.utilities.streamer, Hudi streamer. In packages, we'll provide all the packages that we need for the project. The most probably we need two packages, Hudi Spark package, and then we need Hadoop AWS package. In the property, we are gonna provide the Spark config.property. So if I quickly show you that, this is where you will define, the MinIO credentials, right? So as you can see, the S3 access, secret key, the S3 endpoint, everything is mentioned here. Okay. Then memory, we give the memory jar file. This is how you provide external jar file. Now, what we want to do is, see, after every commit, we want the DeltaStreamer to build the metadata for IceBerg and Delta tables, right? So for that, we are providing these snapshot jars. When you download the project, you should have these jar files. So I'm doing that, and then here I'm providing the Hudi utility -slim bundle jar. This is responsible for the DeltaStreamer. All the classes of the DeltaStreamer is in this particular jar. Okay. Table type, I say I wanna build a copy on write, but again, you can also go for merge and read. Target, I use the Hudi bucket, Hudi test. Did I make one? Yeah, I think I made one. Yeah, Hudi test here, right? This is the MinIO bucket, right? Table name, I just give some table name. Operation as absurd. I'm enabling Hive sync on this, which means I want to catalog the data, right? And then I'm using the sync class as io.onetable.hudi.sync.onetable sync tool. So this allows DeltaStreamer to know, like, hey, you know what? I need to build the metadata after every single commit, right? So it does that. After that, we are reading data from a CSV. So I'm using the class as CSV DFS source. The record key is going to be order ID. I want to partition my transactional data lake by state. For deduping, I'll use a timestamp. Usually, when you have a batch of incoming records and you want to dedupe the data, you would use timestamp to basically dedupe the data. After that, this is the path where your CSV sample dataset is. Again, please change. In my case, the CSV is inside user, Saumil Shah, idea project, Spark project, DeltaStreamer sample. So whatever directory your CSV is, please make sure to change that. Let me collapse this again. I just declare some settings like, hey, my CSV is separated by /t, which is a tab. Over here, I say I want Hudi one table format.toSync Delta and IceBerg, which means I'm saying, hey, DeltaStreamer, when you ingest data, can you guys see? Oh, let me take my photo a little smaller so that way that does not appear. Hopefully, okay. So what I'm saying is, hey, DeltaStreamer, build the metadata for Delta and IceBerg after every single commit. Then we want a Hive sync, so we are using the Hive sync metastore URI. Again, we are spinning up the Hive containers through Docker, so we are providing the URL, right? Hopefully made sense. What else? Then yeah, the Hive sync database, the table name, and etc. Right? So I was able to explain you this complete command. So now what we will do? Let me see if I have my terminal open. Do I have it? Yep, yeah, I do. All right. So the next step we want to do is we'll copy this command, the Spark submit, and we should be able to go to terminal. I know it's a little bit tiny, but when I explain the command, hopefully made sense, right? So simply I'm executing it here. So now what this is doing is from that raw CSV, it will ingest the data into our MinIO bucket. If I can probably collapse this like this. Here I can see the Hudi table on my MinIO. If I click here, So what you will see something great about Apache XTable is you see a delta log. This is the metadata for delta tables, right? You will see metadata where you see the metadata for IceBerg tables, and then you see all the partitions and then the Hudi metadata. This is great. Now, I did talk about the video that, hey, we want to build the multimodal index, right? Which can help us to speed our queries even faster. For point lookup, it's about 70% faster point lookups. We can also use data skipping and features, right? So let's build all these indexes, right? And for doing this, I am showing you doing those in an async fashion, but you can also do it in a synchronous, meaning after every single write, Hudi will do all those, table activities, right? Like clustering, cleaning, compaction, etc. So let's see this in action. So now the first we want to build the record level index, and I'm using a class called Hudi indexer, as you can see over here. I provide the Spark config properties over here, as you can see. Package, same thing. I use the Spark Hudi bundle package and the AWS Hadoop package. Yep. And then I provide the jar file, mode as schedule and execute. So there is two things you can do, right? Either first you can schedule and then you can execute, or you can just do schedule and execute. This is the path where my Hudi transactional data lake is, and I want to build a multimodal index. So I say the index type is going to be record level index. I want to enable the metadata, metadata index async to true. I set that to true, and that's about it. I give some memory. I set the parallelism to 2, and let's build the record level index. So I copy this. On the terminal, I come and paste this here. So this will now start building the record level index for me. Meanwhile, this is happening. I wanna probably navigate you to this blog that I wrote just today morning. I did a benchmarking, and for point lookups, record level index can give you 70% faster point lookups. Again, I don't want to go too much detail into all the technical stuff, but I just want to make sure that you are aware like how it helps us to speed things up, right? So that's that. Meanwhile, let's see. Okay, so my record level index was built successfully. Now we want to do data skipping, right? So for example, what I want to show you quickly without going too much into details. So for example, let's say, let me explain you first. So let's say you said, hey, give me everything from this table where salary or value is greater than something, right? If that particular, let's say you give an absurd large amount of value, which is probably not there in the table, it doesn't really make sense to scan the entire and then say, hey, I don't have anything. So what makes sense is we want to do the data skipping, which means Hudi can leverage this metadata and know which which files to skip. Just like library, right? When you go to a library and say, hey, I want, let's say, Rich Dad Poor Dad, right? You're not going to scan the entire aisles for the book, right? You're going to go to the aisle, and in that aisle, the books are organized by let's say, title or year, etc., right? It's the same concept, right? So we are leveraging the metadata to do all these stuff, right? So we'll build the metadata, we'll build the column stat index now. So again, I'm using the same class, Hudi indexer. Again, same package, same properties. The only thing that you would see here is index type is set to column stats, right? So I'm building now the column stat index too. So I copy that, I paste that here. And now this will build the column stat index as well in an async fashion. For large table, it's usually, recommended, or large or, streaming workloads, performing things in async makes sense, So that's done. Let's go to our MinIO. Hudi. Here you will see indexing requested, indexing in flight, and dot indexing, which also shows that the indexing was successfully done on the table. So great, right? We ingested the data. We saw that the Apache XTable basically built the metadata for Delta IceBerg. We built a multimodal index for record level index and column stats. Now let's see if this is even working, right? Which will, of course, but I want to show you that. So let's read this table now as Delta and then IceBerg and see this in action. So if I go to my code editor, you will see a file called readdelta.py. So as you can see over here, I define my Spark version. The Delta version that I'm using is 2.4.0. I create my Spark session. I set these key and value, which is the MinIO access secret and the endpoint, S3 endpoint. After that, right? I have this Hudi table or Delta table or IceBerg table. I'm reading this as a Delta table now. So if I go here and if I probably do Python 3 read underscore delta.py, this should read the data from MinIO buckets and I should be seeing the Spark data frame, which means I'm able to interoperate now very efficiently, right? I can read this as a Hudi, Delta, IceBerg, whatever that is, as you can see, right? Now, let me show you the IceBerg part. So if I probably go to a Python file called read iceberg.py, same thing. We use the IceBerg version as 0.12.0. We create the Spark session, we set the key and value for MinIO, and then we read the table as IceBerg, right? So again, same thing, Python 3 read underscore iceberg.py, and I should see my IceBerg table printed on the console, hopefully, which is Hudi, which is Delta, same thing. All right, so makes sense, right? So what you see is that right now I am using MinIO as my object store. I'm able to read this as either Hudi or IceBerg or Delta, and I can interoperate between them. And to streamline my data ingestion, I'm using a DeltaStreamer, which helps me to ingest data much faster and a streamlined approach from various sources such as JSON, CSV, Kafka into Hudi transactional data lake, and then it can also build the metadata for IceBerg and Delta. Great. So far, everything made sense, right? Now, let's see other things in action, right? So that's that. Now, all right. So that all made sense, right? So let me go here now. What I want to do is I want to show you how you can query this using StarRocks, of course. So let's go to that part. So I'll copy this code snippet. I'll head over to my Docker desktop and I'll go to my StarRocks FE. I go to exec and I paste it. Here I see my StarRocks shell, and now I can create an external catalog. So as you can see, it's super easy. So let me quickly show you. Create external catalog, Hudi catalog HMS properties, and we then provide the properties. Type to Hudi. You can also use type to Delta or IceBerg. The Hive metastore type is going to be Hive. This is the metastore URI. The AWS access secret and the endpoint, because it needs to find those files, right, eventually. So now let's copy this. Okay, we got the query. Okay. And now what we can do is we can set the catalog. Okay, so we'll do that. You guys can see, right? Hopefully the font size are visible, right? I just want to make sure that you guys can see carefully, right? And now I'll do show database. So I should see all the databases there. I can see my default, right, database over here. I can do use default, and then I can do show tables. I can see my bronze table over here. Select everything from bronze table limit 5. So let's run the query on StarRocks. Now this will query the data, and I should see the data on the console. The beautiful thing about StarRock is if you run the same query again, look, 0.08 seconds. If you run again, 0.10 seconds. If you do it again, 0.06 seconds. So it's becoming more faster and faster, right? So that's that, right? Now, hopefully this complete made sense, right? Now, to do the data skipping in action, right, or do point lookups, right, placing fast point lookup, since you have these indexes enabled, right, you made these indexes, right, you can perform data skipping, point lookups, everything in action. I don't want to go too much detail, but I would definitely show you the script for that. So allow me to show you that. Dataskipping.py. Okay. Okay, so simple, right? We create a Spark session over here. We provide the MinIO access secret and the S3 endpoint over here, as you can see. After creating the Spark session, we provide the path to our Hudi data lake, or it's IceBerg, Delta, however you're like reading it. And then I'm simply doing this spark.read.format. So I'm reading the data as Hudi, and then here I'm providing 4 options, and this allows to basically do data skipping, or if you're doing point lookups, you can get 70% faster point lookups. So Hudi.enable.data skipping, we gotta set that to true, and then we have to say Hudi.metadata.enable, we gotta set that to true as well. Then Hudi.metadata.index.column_stats .enable to true. So basically we're setting the column stat, the metadata, and as you can see the Hudi metadata.record.index or unable to true. So basically I'm setting all the index to true, right? Hopefully made sense. Now to show you the results, again, this query would work fine. I've done my benchmarking over here. So what I want to show you, if I can probably show you. So for record level index, right, when you're doing point lookups, right, when I say point lookups, I mean like this. For example, select everything from a database where customer ID is equal to something. So when you're searching something on the primary key, those are blazing fast since you have the record level index, right? And since you have data skipping in action, so for example, if you run a query like this, for example, select something from this particular table where salary is greater than equal to some absurd amount, right? Now we know, like guys, that this amount is not there in the table. So without the metadata, the naive way would be to go scan everything and then filter it, right? Which works, but not the best, right? But with data skipping, it knows that the max value, what is the min and the max, right? So it knows that this particular probably entry is not there in the table, right? So if you see the Spark UI, you can see clearly, right, that number of output row is 0, right? Hopefully this made sense, right? I have this blog. You can come and read more about it if needed, right? So this is query 1, and this is again query 2. Look, so number of file reads is 0 over here, and in the first case we had 50 file reads. So as you can see, first, right, without the data skipping, right, when I ran some query, it basically scanned all the files, right? But after enabling that, as you can see over here, right, just look at this number of file reads to 0, right? So you see what I'm talking about, right? So I hope this video was useful, and I think there's a lot in this video. We did first of all, we learned how to ingest data into Hudi transactional data lake using DeltaStreamer. We learned how to leverage Apache XTable to interoperate between IceBerg deltas, because Apache XTable built the metadata for all the 3 lakehouse format. After that, once that was done, we basically saw how to build a multimodal index. We saw how we built a record level index on the top of our table. We also built our column stat index. We read the data. We read the same data in the MinIO as Delta, as IceBerg. I showed you the script for that. That was working. I also showed you the script for the data skipping. And also what I'll do is I'll leave all the 3 blogs also. So in case if you want to dive further, you can surely do. So that's all I have for the video. I know this video is quite long, but I hope this video is informative, because usually you won't find such deep technical content on the YouTube or on the internet. I want to make sure that I take out the time and I share the knowledge with you all. Thank you very, very much for watching. I hope you enjoyed. In case if you have questions, I'll try my best, because I get a lot of questions every day. It's usually sometimes hard to reply everybody, but I try my best to follow up with as many questions as I can. So with that said, thank you so much for watching the video. I hope you have enjoyed. I hope you have learned. And I hope you enjoyed in general. That's all I have for the video. Thank you so much, and I'll see you in the next video. Thank you, guys.